everyone. Today we'll in the series of theory of computation lecture, we'll see what is minimal DFA and how to construct the minimal DFA for a given problem statement, or even for a given DFA you have to minimize that DFA. Okay, so we'll see what is minimal DFA. Okay, what is meant by minimal DFA? DFA which has minimum number of states are called minimal DFA. So when you're transforming the given DFA into a equivalent DFA, that particular equivalent DFA will have minimum number of states. Okay, so that is called minimal DFA or minimized DFA. Okay, so in the previous lecture we were discussing about number of states, how to find out number of states for a given problem. Okay, so we were discussing three formulas. The first one is when the length of the string is equal to n. So this is the case when the length of the string is equal to n, then we'll have a formula like n plus 2. You will have n plus 2 number of states, and when the length of the string is greater than or equal to n, the length of these states, the length of the string is greater than or equal to n means you will have n plus 1 states. Number of states are n plus 1. In this case also you will have, when length of the W is less than or equal to n, you will have n plus 2 states. Okay, so but here also you have n plus 2, here also you have n plus 2 states. Here also we have, when I say the length of the string is 2, I will have 4 states, which means 2 plus 2 I will get 4 states. Here also when I say length of the string is less than or equal to 2, I will have the 4 states. But the thing is, the final state and starting states will vary here. So when I say length of the W is equal to 2, the length of the string is equal to 2, so which means exactly 2. Now the length of the string exactly 2. So in that case I cannot accept 0, either 0 or 1, or even which is greater than 2. So in that case we are making only this third state as a final state. Okay, but here when you see the length of the string is W is less than or equal to 2, which means that you will have at most 2. At most 2 you can accept, the finite automata will accept at most the length of the string 2. Okay, so in such case what will happen is, you have to accept what? Even if you get null string you have to accept. Okay, so even if you have length of the string is 1, that case also you will accept that. And if the string is 2, that case also you will accept. When it exceeds 2, when the length of the string is exceed 2, you will not accept. So this is what the meaning of at most 2. So in that case these 3 states will become a final state. So this fourth one will become a dead state. Okay, here the third state will be a final state. That is the difference between these two. Okay, but when you say the length of the string W is greater than or equal to 2, this is the formula, that is n plus 1. So which means you will have n plus 1, 2 plus 1 states, which is 3 states. So again here what is the meaning of this? At least 2, greater than or equal to 2, in the sense you should have at least, the length should at least 2. Okay, which means it may go beyond 2 also. So 2, 3, 4, like that it will accept. Okay, that case the diagram will be like this. The third state will be a final state, but you will not have one more state after this. So only will have only three states. Okay, so this is what we have learned in the previous lecture. So and today we'll see how to construct a minimal DFA for a given problem statement. So just to look into the problem, construct minimal DFA for the W over the set A comma B. Okay, A comma B, where the length of the W mod 2 is equal to 0. What is the meaning of this statement? What is the meaning of this mathematical statement? So which means that the length of the string is divided by 2. Okay, exactly divided by 2, which means what is the meaning of that? So you would have learned in the mathematics 0 mod 2, you will get what will be the answer? 0. 1 mod 2, what will be the answer? 1. 2 mod 2, what will be the answer? 0. 3 mod 2, you will get 1 as the resultant. Okay, reminder, 4 mod 2, you will get 0. Likewise it goes on, which means this 0 1, 0 1 will be repetitively you will get the remainder, right? So in that case, so when the length of the W is divided by 2, so this is the statement, so which means it divides 2, right? The length should be divided by 2. So what are all these length is divided by 2? 0 is divided 2 is divided 4 is divided by 2. So which means my set L contains 0 in the sense the length is 0, which means I can say it is an empty string. And then 2 means I can have over the set A comma B, I can have combination of AA BB BA BB. And also I cannot have 3 because the mod of 3 mod 2 will become 1, right? So this will not satisfy. So you will take 4 means from the set A comma B you will have combination, right? A B like that, the set goes on, right? The set is infinite set, right? So in that case, this is the set, this is a member of elements, okay, of the set L. So you have to find out the number of states here. So whenever you see this kind of problem, what you can say is that you are getting either 0 or 1 as the resultant state, right? So in that case you are having two states, okay? So this is the number of states here. So I can have 2 states here. One is for even number, another is for odd number. Okay, I can have this as a starting state. I only have 2 states here. So first you just make it as one by one, you just read the string. So first you are having the empty string. So if the finite automata scans the empty string, it should accept. Okay, this is a member of the language, right? So which means that I have to make this state as a final state. Okay, and then you are taking this string. Okay, so A when I receive A, I am going to this state, and then I am reading another A. I will come to here. So I am just reading A, so it comes to final state. So this string is accepted now. And then AB. So first you are taking the string A, and then the automata reads the symbol B. So which means I can have B here. Okay, here when you see here, what is the member here? BA. So B is the starting symbol. So I can have B here. First I can accept B, that is I can read B. Automata will read B, and then it will read the A. Likewise BB. Okay, likewise you can have a number of whatever strings you are having here, that will be accepted by this automata. Okay, so if you notice this is the, it will accept only the even. This is the state which will accept even number of the strings with even number. This states getting the string with the odd number. So this is for even, this is for odd. Okay, the states denotes this is for even number of string, and this is for odd length of string. Okay, so this is the finite automata construction for this problem statement. Okay, so likewise here what they are asking, the length of the string W mod 2 is equal to 1, which means what is the meaning of that? So which means that the length of the string is, when you are dividing that string, the length divided by 2, you are getting the remainder as 1, right? So 1, right? So which means what will be the member of this string, member of the language? So I will not take this one. So we are telling the remainder should be 1, right? So I can have 1 in the sense 1, the length should be 1, right? So I can take either A or B. Okay, 1 is over, and then 3, I should take 3, right? The length 3 in the sense triple A, right? So here you can make a combination, right? A B B. Likewise you can have a combination, it goes on, and then you will not have 4, but again you will have 5, right? Likewise it goes on, right? The set is again a infinite set. So for this string, for this language, you have to construct a finite automata. So again I am telling, whenever you are having the formula like this, which means you will be having two states. So here we are accepting only the odd length of the string. So which means this is, when I get 1A, I should accept. So this states is for odd, this stated for even, this represent even length, this represent odd length of the string. Okay, so when I get A, I will accept. When I get B, I will accept. When I get A, so A, we are reading again A, so another A. So 3 times 3 A's are read by the states. Okay, if I say triple B, so what will happen? BB. Okay, so likewise you can have it. Okay, this is the finite automata construction for this statement, problem statement. Okay, I hope you understand both these things, right? When I say the length of the string mod 2 is equal to 0, you will have two states. Okay, this is the number of, this denotes the number of states. Okay, here I am also having another problem here. The length of the string w mod 3 is equal to 0, which means that the length should be divided by 3. This is the problem, right? What is that? You know what? 0 mod 3 will get 0. 1 mod 3 will get what? 1. 2 mod 3 you will get 2, right? 3 mod 3 you will get 0. 4 mod 3 you will get 1. 5 mod 3 you will get 2, right? 6 mod 3 you will get 0, right? Which means 0 1 2 0 1 2, these things are repetitively coming, right? The reminders 0 1 2 0 1 2 are repeating, right? So in this case you will have 3 states. Okay, you will have 3 states. Okay, so as I already said, this denotes the number of states. So now what will be the member of this language? You just try to identify the member here. So you can take the string should be, the length should be divided by 3, which means I can take this one, right? Divided by 3. So which means I will have epsilon here because 0 is divided by 3. So it gives the reminder as 0, right? 0. And then epsilon, right? And then you will have, you will not take these two, you will take 3, right? 3 means the number of length is 3. So over the string a comma b, we will have triple a, otherwise triple b. Otherwise you can have combination. Okay, different combination. And then you will not take 4 5, you will take 6. So 6 means 6 a's. So here you will have different combination. So this is again an infinite set. The language L is the infinite set. So for this I am telling 3 number of states. Number of states for this problem statement is 3. So you will have 3 states. So first of all you are having the empty set. So definitely you will make this first state as a what, a final state, and you have a. So you are reading a, you are getting again a, and then again you are having a, which is going to final state. So this is accepted. And then triple b, so just to make it for triple b, so b. So again this is accepted. When I say a b, that will be accepted. So this is the perfect automata for this given problem statement. Okay, so I hope you understood what is this. And now please note that whenever I have the formula w mod n is equal to 0, when I say the modulus of, that is determination of w, the length of w is divided by n, the finite automata will have n number of states. So if this statement is true, then I will have n number of states for a automata, for a construction of DFA. Okay, so just to remind this note in mind. Okay, so I hope you understood this thing. So we will revise one more thing. So construction of minimal DFA, you want to construct a minimal DFA for this problem statement, that is the modulus of w mod 2 is equal to 0, which means you have to understand the meaning of that statement. So which says that the length of the string should be divided by 2, that is what is equal to 0. When I apply mod operation, if I am getting 0, which means that length is perfectly divided by 2. Okay, so which means these are all the members of this set. So why I am adding this epsilon? Because 0 mod 2 I will get 0, right? 0 mod 2 is equal to 0. So I am taking this epsilon as a member. The same case here, I am getting the remainder as 1. So I am starting from the string a, that is the length with 1. Okay, so this represents even number of state, even length. This represents odd length. Okay, you can also have an You can also name the states. Okay, you can name anything, q0, q1, q2. Okay, so now you take one more problem. Okay, so one more problem just from this understanding. I'm just giving a problem statement for you, so try to solve it, and if you don't know, we'll discuss in the next class. Okay, so what is the length of the, when I say this is a problem statement, right? It's equal to 0, so I am making it as w mod 3 is equal to 1. Okay, and w mod 3 is equal to 2. For this you have to make a finite automata. Okay, if you understood what we were discussing, you can able to come up with the diagram for this given statement. Okay, which means when you are dividing the length with 3, you will get remainder as 1. And another case, this is one problem, this is another problem. So in the second problem, when you are dividing with 3, the length of the string, when you are dividing that length of the string, you will be getting 2 as a remainder. Okay, for that you have to make a construction. Okay, I'll give the clue for that. So this state represents the reminders. So reminders, this represents 0 reminder, because when you are saying 0, I am making this as a final state. When I say 1, I will make this as a final state. When I say reminder is 2, I will make this as a final state. So I have given the answer also. Try to come up with the answer for this 2 problem. So we'll see the remaining thing in the next class. Okay, thank you.